Hi all, and welcome to this Conf42 session called Hacking OpenTelemetry. My name is Andrea Caretta, and I'm a senior consultant for Liquid Reply IT company. And I'm here with my colleague Alberto Gastaldello as observability expert. Our job consists in searching and or designing monitoring solution for system at full stack levels, infrastructure, applications, and front-end user behavior, adopting both enterprise platform and open source tools, reason why our path collided with OpenTelemetry and we never left that way. Just a quick summary about what we're going to show you today. We would like to start with a brief introduction about how we handle observability and we consider it so important, proceeding with the clarification of what OpenTelemetry is. We will mainly focus on distributed traces, one of the three observability pillars, in order to explain how we managed to hack the tool, but be careful, it's not properly or only a tool, we'll see later, and transform the collected data, showing also a little demonstration. So let's start with few observability tips. In system theory, observability is a property able to measure the level of internal states determination and interpretation given input data and external output. It's a system attribute, of course, and not an activity or a tool. I could adopt tools to reach observability, for example. It's a kind of a mindset instead of a result. The disposition to realize a system not only to work, but in addition to be observed, to be seen. Let's represent my system as an iceberg, where the visible part is a kind of a black box where I'm able to understand information only through outputs, through symptoms, explained with the red matrix, request rate, error, and duration. I have to open the black box in order to understand the causes of the outputs, adopt the use metric, utilization, saturation, and errors to perform the root cause analysis. Logs are important, the same as a diary of the system events and many additional pieces of information. Traces instead are able to correlate user behavior with the last query performed on the DB, introducing a cause-effect concept in a single occurrence compared to the aggregated values of the matrix. All of them contribute to fully understand the system behavior both in fully operational and anomaly situation. So what is OpenTelemetry, or better, why OpenTelemetry? OpenTelemetry was stated as a standard de facto for observability during the last years. Many leaders, cloud providers, or enterprise observability platform companies contributed to its development, starting as a framework spread in different programming languages. Then it was included in the CNCF as an incubating project, where every pillar for which OpenTelemetry defines semantic rules and references as a maturity level, only traces specs was released as a stable version. And this is one of the reasons we're mainly focusing on this pillar instead of the others. Finally, new softwares with different purposes than monitoring started to adopt OpenTelemetry standards to generate valuable telemetry data and provide them to external tools out of the box. These kind of solutions are really important to understand where the market is going. OTel is vendor agnostic, since new companies are not always so confident to let agents to be installed on their products. On the opposite, they prevent every kind of external monitoring. As I said before, OpenTelemetry defined data types, operations, and semantic conventions in the beginning, and it officially born as a framework composed by different SDKs in different languages to be included in an applications project. Then monitoring capabilities were synthesized in agents able to instrument scripts and virtual machines, in Java, Node.js, Python, .NET, and many other technologies. And after a while, a Kubernetes operator was created in order to instrument pods with agents in microservices clusters. So we currently have the chance for supported technologies to obtain data out of the box without touching any line of code. Last but not least, the OpenTelemetry collector is one of the most important artifacts in the project. There is a kind of proxy able to receive OpenTelemetry data in different formats, editing and or filtering it, and sending it in different formats to the desired backend. Taking a look to the data flow, it's clear how its role is fundamental in environments with heterogeneous data sources to translating in expected format the information and convey them to target in different protocols, different compressions, and different serializations. The most important thing to understand from here on out is that OpenTelemetry Collector is the tool we hacked to perfectly and fully handle telemetry data. So let's go deeper inside the distributed tracing world. Alberto, tell us your point.
Thank you, Andrea. Let's start with the definition of the three fundamentals concept in distributed tracing. The trace is the word request record that follows the path top-down through the architecture of a system. A trace is composed of spans that are like a measure unit in this field. Each span contains all the details of operation that are made within a service, allowing us to know how much time the step has taken. But how can we correlate all spans that are related to a single request? The tracing context, defined by W3C in 2021, allows to propagate span data with the trace parent and the trace state headers. I'd like to point out three more important definitions that I'll use throughout the webinar. The trace ID identifies the whole distributed trace. When a span is created, a unique ID is generated for it, and that is the span ID. As the request propagates through services, the caller service passes its own ID to the next service as the parent span ID. Trace ID and parent span ID are then included in the trace parent header. Let's see together an example of distributed application. This is SockShop, an open source demo application. It is the usual website architecture. We have a front end, various other microservices in the back end, with two databases and a queue manager. Order, shipping, queue master, and cart services are auto-instrumented using the OpenTelemetry operator. When a request is received by the backend, a trace is generated. As the request propagates then through components, spans are added to the tree. All this data is sent to the collector that eventually processes it and then forwards to dedicated storage backends. Let's see how this works. We open SockShop web page. We choose an article and then add it to the cart. Now we are opening the cart and proceeding with the checkout. Let's see what this last click generated in our observability tracing backend. Each span represents a step in the request timeline. We can reconstruct the path followed by the request. For example, orders call chart services and then the shipping service. I'm showing you these two tools to highlight the fact that both an enterprise software like Dynatrace and an open source one like Grafana show traces in the same way, thanks to the standard data format. Okay, all nice and clear, but what happens when we do not have the possibility to export tracing data? Can we make the system observable in some way? Fortunately, the answer is yes. Let's see how. In many situations, we encounter applications that are not instrumentable due to restrictions imposed by software providers. They just send out logs that are then stored in a database, eventually passing through a telemetry processing layer that decouples the application and the backend. Unfortunately, in this way, we only deliver data for the second observability pillar, logs. For the sake of simplicity, we'll leave out the metrics pillar and focus on the traces from now on. When application logs contain tracing data, that is, as said, trace ID, span ID, and parent span ID, this is all we need to correlate them. In order to transform a log into a trace span, we can leverage the processing layer. We use the hotel collector for this, and now let's see how it works and how it can be manipulated to reach our goal. The collector is composed of three main modules: receivers, processors, exporters. The receivers accept telemetry data with different protocols. Processors allow data filtering, modification, or transformation. Exporters send that elaborated data to endpoint storage. There are two collector versions, the core and the contrib. This last one includes the core modules and all the additional modules developed by contributors for their purposes. As you can see, collector components are defined in a YAML config file, listed in their own sections, with the chance to customize them with many comments. The highlighted section is the service section, where pipelines can be configured and each component can be enabled only in the step it is made for. We have to be careful about the pipelines in the hotel collector releases because they are fundamental to understand from here. They arise from pillars division and they are really independent from each other. A trace information received could be only handled as a trace and sent anywhere as a trace, same as metrics and log at every step. What we found out breaks this model. We paid our attention on logs pipeline and we detect a point in which information could be manipulated to switch from a structure dedicated to logs to another structure related to another pillar. In this case, we were interested in trace structure. We built an exporter able to retrieve trace ID and span ID values contained in the log and represent them as key values for spans before sending them to a target able to represent distributed traces. With an application able to produce only logs, meaningful logs with tracing IDs, we have in the end all we need to create correlated spans and so distributed trace. The translation takes place in the collector. It leads to a well-formatted trace span that becomes a fundamental piece across the end-to-end path, where a trace before could have been broken. Then, the modified exporter forwards the log to the log storage, in our case Loki, and then the trace in the tracing backends, for our case Grafana Tempo and Dynatrace. Let's now see how this works with a demo. We compiled our modified version of the OpenTelemetry collector, and now we run the executable in order to have the service listening on a local port. We created a Python script that simulates an application sending event logs. It sends logs in the syslog format to the local port of the collector that is running locally. We decided to focus on modifying the exporter. At the chain level is the last point to modify data before transmission. The collector takes each log and transforms it into a trace. Then sends the original log to Loki and the trace to both Grafana Tempo and Dynatrace. Let's open our tools to see how this can be visualized. In Grafana, we have the possibility to see logs and traces in the same dashboard. With a Loki query, we can find our generated logs, pretty formatted in JSON for better visualization. This highlights the switch from the logs pillar to the traces pillar. From here, we can directly find the corresponding trace thanks to the integration that queries Grafana Tempo looking for the trace ID. The visualization is pretty straightforward. The same can be seen in the other tool, dynatrace. We navigate into distributed traces and visualize the trace generated by our Python script. Today, you saw how to manipulate and transform telemetry data for your purposes. When complex distributed systems handle data adopting different formats, OpenTelemetry allows you to define pipelines and move data wherever you prefer, becoming agnostic from every type of source. Thank you for watching. For any question about this session or our offer, feel free to reach us through socials or via email. Bye!